Thanksgiving break. Got to relax some, rest up. We got 3 weeks before the next break, Christmas break, winter break. All right. So if the sub has not passed this out, you need to ask them to pass this out. It's a single page notes. Um, it looks like this on the front, this on the back. Okay, you need to have this to follow along with and take your notes. They also should have passed out a blank unit circle. Looks like this, and it would be on cardstock. I think it's like on blue or purple or like a gray color. There was a few different colors, I think, but a cardstock piece of paper with this unit circle on it you also need. Okay, so we are continuing in Unit 3. We had just touched on it before the break. We mixed part of it in with the end of Unit 2, talking about radians and angles around the unit circle. So to start, I kind of just want to refresh your memory on those angles. So actually these, I think we had this table in a previous notes, and I had listed these as like the important angles that you really need to know the radian measures for, because these are the angles in quadrant 1, 0 to 90, and then the 3 special angles, 30, 45, 60 in between. And then 180, 270, and 360 are the quadrantals. They're like when you're on the X or Y axis. So I'm actually going to start with that and get that filled in. There are a lot of blanks on this blank unit circle. You're not going to fill all these in today. Just leave it blank unless I write in it and tell you to do the same. Okay, so we're going to start with, we'll go ahead and start with angle the degrees. Okay, refresh our memory on, why is this all highlighted? Cut it out. Okay, there we go. So we're going to start here on the positive side of the x-axis. Okay, and we know that that would be 0 degrees, because this angle in standard position we always measure from the positive side of the x-axis. That's our initial side of the angle. And then rotating counterclockwise, so up into quadrant 1 through 2, 3, 4, this direction, that's our positive angles. So going through here, this is 0 degrees. This first terminal side that's drawn is our 30-degree reference angle. 45, and then 60. And then if we go all the way to the y-axis here, that's a 90-degree angle from here to here between the x and y axis. And these were the you needed to know. Okay, so if I continue counting around this circle, each of these quadrants has a 30, 45, and 60-degree reference angle. Remember, reference angle, the x-axis. So like if I were to fold this over this y-axis here, these two would match up. That means this is 60 degrees from this side of the x-axis. This middle one is, this one is 30 degrees from the x-axis. Okay, but we're not going to write 30, 45, and 60 there, because we don't measure from the negative side of the x-axis. It's always measured over here from 0. So when I'm going in this direction, I need to remember that this is 180 degrees. It's a half a circle. Okay, and if I went all the way around full circle, that's 360. Okay, so the only other one from that chart that we're missing here is the 270, which is 180 plus 90, because each quadrant is a full 90 degrees. So if you went around by 90, it'd be 90, 180, 270, 360. Okay, now you can use that, as long as you know that, to fill in the rest of these missing degree angles, knowing that these are all either 30, 45, or 60 from the x-axis. So if I'm 30 degrees away from 180 behind it, okay, I'm at 150 degrees. If I'm 45 degrees from 180, so it's 180 minus 45, I'm at 135. And if I'm 60 degrees from 180, I'm at 120. Okay, and you could do the same thing. In quadrant 3, you're 30, 45, or 60 past 180. So you're adding 30, 45, and 60 to 180 to fill these in. And in quadrant 4, you're measuring from the 360. You're behind the 360. So it's 360 minus the 30, minus 45, minus 60 to fill these in. Okay. Another way to think about it, and you don't have to write this on your unit circle unless you want to. It might, maybe it's helpful. But when you're filling in the degrees, I'm going to write it at the top in case anybody wants to put this down. Okay. It's a pattern. You go plus 30, 15, 15, 30. This is what you're adding to get from where you start to the next one. And you continue that pattern in each quadrant. So for instance, I started at 0, I went plus 30, and that got me to 30. Plus 15, that got me to 45. Plus 15 got me to 60. Plus 30 got me to 90. Now I do it again. I say plus 30, that gets me to 120. Plus 15, plus 15, plus 30. And then I continue it again. So 180 plus 30 is 210, plus 15, plus 15, plus 30 gets me to the 270. And I do it again, plus 30, plus 15, plus 15, plus 30 gets me to the 360. So you can use the pattern to fill in your angles in your angle measures in degrees, or you can use the reference angles and just know you're going 30, 45, or 60 from the x-axis. So either counting from 0, 180, or backward from 360 to fill those in. Okay, so you should have all of those angle measures filled in degrees around the circle. Now we're going to do the same thing in radians. I'm going to take it back to the notes real fast. We talked about our radian conversions, and the ones that you needed to have memorized were those initial first ones we filled in on that circle. Okay, so 0 degrees is 0 radians. And then we said 30 degrees was pi sixths radians. And 45 was pi fourths. And 60 degrees was pi thirds. 90 degrees was pi halves. 180 was just pi. 270 would have been 3 pi halves. And 360 was a full 2 pi. Okay, so we're going to go ahead and go back to our circle and fill that in. So we said this is 0. We know that half a circle is pi. A full circle is 2 pi. So refresh our memories that we did before the break. We said, okay, halfway to pi, because 90 is halfway to 180. That's pi over 2, or pi halves. Okay, so every 90 degrees is 1/2. So if we look at 0 halves, 1/2, 2 halves is a whole pi, 3 halves, so this is 3 pi halves. 4 halves is 2. So 4 pi halves would just be 2 pi. And then we talked about, we went through at the quarters. Okay, so half of 90 is 45. So half of a half is a quarter. And we talked about how this is a quarter. Oops, getting too much there. This is a quarter of the way to 180, because 180 divided by 4 is 45, or 180 divided by 45 is 4. That's where you can get your denominator. Okay, 180 divided. Divided by 30. This is pi sixths. It's a sixth of the way to pi. And then 180 divided by 60 is 3. So this is pi thirds because it's a third of the way. Broken down in your earlier notes before the break, we had broken down going around and filling in these angles in radians, counting by pi halves, and then counting by pi fourths, by pi thirds, and then or you can just make sure you understand that those that reflect over into the other quadrants will have the same denominator. So for instance, everything that is a 60-degree reference angle, so I'm just going to highlight here. So each of these that we said was 60 degrees away from the x-axis. So that's the 60, the 120, the 240, and the 300. All of those will be a third of something pi thirds. Okay, now how many thirds? Okay, so this is a whole 3 pi thirds. 3 thirds is 1 pi. So this is 1 short of that. So 1 less than 3 is 2. So 2 pi thirds. Okay, you're going into quadrant 3, it's 1 more than that. So more than 3 is 4. So 4 pi thirds. Okay, and then 2 pi, that's a full circle, would be 6 thirds. So 1 less than that is 5 pi thirds because your reference angle is 1 pi third or 60 degrees. Okay, and then we talked about and did the same thing with fourths. So all of those that are a pi fourths or a 45-degree reference angle, the ones that are in the middle of each quadrant, are all going to be a fourth. They're going to be something pi fourths. Okay, so then a full circle would be 4 fourths. So 1 less than that is 3. 1 more than that is 5. 2 pi, a full circle, would be 8 pi fourths. So 1 less than that is 7. Okay, and then we do the same thing with the sixths. So the pi sixth, those are your 30-degree reference angles. Those are these that are the terminal sides closest to the x-axis. They're the smallest angle from the x-axis of the special ones that we label. So they're all going to be a sixth. So a full pi, a semicircle, would be 6 sixths. So 1 less would be 5. 1 more would be 7. 2 pi, a full circle, would be 12 sixths. So 1 less is 11. Okay, so radian and degree review from before the break. Hopefully you can get that filled in on your circle. So going back here, I could now look at and find that these are angles that I just labeled on my unit circle. But I need to be able to convert anything that is in reduced form. I need to know that pi fourths is 45 degrees because then I can just do 3 times 45, that's 135, without looking at my circle. Okay, remember the long conversion is to multiply by 180 over pi. You reduce the pi's, then you'd have to do 7 times 180 and then divide by 3. So it would take a little bit of work. But if I just know pi thirds, that's 60 degrees, I just have to do 7 times 60. And 7 times 6 is 42, so that's 420. Now that one's not on the unit circle because it's bigger than a circle. It's bigger than 360, but it would be coterminal with one of those angles on the unit circle. Okay, or this one. If I know pi sixths is 30 degrees, I just have to do 5 times 30. That would be 150. So that's quick conversions using that. As long as you know those denominators, okay, it makes converting much quicker and easier. than having to go actually multiply by 180 over pi and doing all of your reducing. All right, now this picture is actually from the last set of notes we took. I'm just repeating it since it's been a little while, but this is the unit circle. Okay, so the unit circle is just a circle that has a radius of 1 and it's centered at the origin. Okay, so this center is at 0, 0, and this distance from the center to the edge of the circle is 1 unit. So that means that this point would be at 1, 0. This point at the top of the circle would be at 0, 1. This point on the left edge would be at -1, 0. And this point at the bottom would be at 0, -1. Because the radius doesn't matter what direction you're going, it's 1 unit in length. So if that's the 0, 0, and this is 1 unit long to the edge of the circle in any direction, that's what those 4 coordinates would be. So we're going to go ahead and add those to our unit circle as well. Okay, and I've got the parentheses with the comma in the middle for ordered pairs. So this ordered pair is at 1. Oh, hang on, let me get a different color. I already used pink for radians. Let's do blue. So this is at 1, 0, 1, and 0, -1. And make sure that you can see when we put a negative, because the negatives are very important when they are there. You need to make sure that you see them. All right, so this is what we've got so far. Our special around the unit circle at the 30, 45, and 60-degree reference angles, I need to know what these ordered pairs are if the terminal side is at those given angles. Okay, and this distance, this circle. Okay, so to do that, I'm going to use the special right triangles. So the first one we're going to talk about is the 45, 45, 90. So you may remember when you have a 45, 45, 90, that's an isosceles right triangle. Okay, so if these two angles are both 45, that means these legs are congruent to each other as well. Okay, the ratios for an isosceles right triangle are that the legs are x and the hypotenuse, so across from the 45s are x and across from the 90 is x root 2. So whatever these legs are, they're the same, and it's that distance or that length times the square root of 2 is the length of the hypotenuse. Well, if I'm talking about being on the unit circle and knowing that this is a 45-degree reference angle, I can sketch a right triangle to that point using the horizontal and vertical distance. That's what the coordinate is. So this is the x and the y of this ordered pair for this point. And if this is the unit circle, we just got through talking about how on the unit circle the radius is 1. So the hypotenuse is 1 unit long. So across from the 90, I know this is 1 unit long. So I can label that there. So what I do is I take the side that I know and I set it equal to the formula for that one, for that. So 1 is x root 2. And I need to solve for x, so I know what these lengths are. So this is x times square root of 2. So to get rid of that, I will divide out the square root of 2 to get x alone. So I've got 1 over root 2 is x. But you hopefully remember, we do not leave radicals, square roots in the denominator of fractions. So we have to remember to rationalize. So remember, when we rationalize, we're multiplying by the radical we're trying to get out of the denominator. Because when we do that, any radical multiplied by itself is just the number underneath. So that just leaves me with a 2 there. And I have to do what I do to the denominator, I have to do to the numerator. So root 2 times 1 is root 2. So I end up with root 2 over 2. That's the x value. So I labeled that in the table and in my picture. Now what that means is the horizontal and the vertical leg, because it's isosceles, they're the same. That's this distance that we're going to get to this point. If this hypotenuse is 1, this is root 2 over 2, root 2 over 2. So that is the ordered pair. Root 2 over 2, root 2 over 2. So I can fill that in on my unit circle. And that's at the 45-degree reference angle. I don't know why. All of a sudden, my pen, there we go. Root 2 over 2, root 2 over 2. So that's the ordered pair at 45 degrees. So then I'm going to come back. I'm going to say, okay, what about the 30, 60, 90? That was our other special triangle. Okay, so if this is a 30, 60, 90, okay, again, I want to get to this point. I'm going to say the 30 degree is the central angle at the origin. This is the origin, 0, 0. So if I'm going to draw my triangle, I need to know how far I'm going over and up, because that's going to be my ordered pair if the hypotenuse is 1 again. Okay, so here, the ratios that you need to remember is that the short leg, the one across from the 30, is x. The hypotenuse is double that, it's 2x. And then the long leg, the one across from the 60, is x root 3. Okay, and that's what those ratios there are for. Now the one that we know is the hypotenuse is 1. I know that that's 1 because this is the unit circle, so this is 1. So again, we're saying these are equal to each other. So 2x is 1. So I need to solve for x. To solve for x here, I would divide out the 2. Now this time there's no radical, so I don't have to rationalize or anything. It's just x is 1/2. That's it. So x is 1/2. So that means that this side that's labeled x for the special right triangle ratios would be 1/2. That's this vertical measure. Now if x is 1/2, and to get 60 we do x times root 3, we're doing 1/2 of root 3, or root 3 over 2, half of root 3. So that's this length here, the horizontal distance. So for, hi. So as far as this ordered pair goes, the x, it's not the x, this is from the ratio. I know that's sometimes confusing, but when we talk about x, y, like plotting a point, x is the horizontal, y is the vertical. So 1/2. That's when it's a 30-degree reference angle. So I'm going to go back to my unit circle. I'll say okay. Root of 3 over 2, 1/2. Last but not least is going to be the 60-degree reference angle. We're going to say, well, we already talked about 30, 60, 90. It's the same triangle. So that the base angle here, the central angle at the origin, is now the 60 degree. So we just rearranged the triangle. This is still a hypotenuse of 1. It's just now the 30 is up here and the 60 is down here. So it's this triangle has been kind of like flipped over, okay, to pull the 30-degree angle up at the top. So when we do that, across is still the 2x, which we're saying is 1. Across from the 30 is still x, which is 1/2. And across from the 60 is the root 3 over 2. So here across from the 60 is the vertical. So nothing changes in that table. This triangle's just been rearranged. So now this is 1/2 and this is root 3 over 2. So the only thing that happened is the x and the y switched. So now the x is 1/2 and the y is root 3 over 2. So now we've got the ordered pairs for those special angles in quadrant 1. Now, I've already highlighted to color code to show you that these reflect over into the other quadrants. So what I want you to try doing is reflecting over. So all of the 30-degree reference angles, the distance from the center is going to be the same. The horizontal and vertical distance, it's just going in a different direction, but the distance is the same. But instead of going to the right, square root of 3 over 2, and then up 1/2, it's going left, square root of 3 over 2, and then up 1/2. So the only thing that's going to change is some of these will change to negatives depending on what quadrant you're in. Okay, so in quadrant 1, everything was positive because X and Y, you go right and up, right and up, right and up. Those are all positive movements. In quadrant 2, we're going to go left and up to all of those. So a left, that makes your X negative. So all of the X's here need to be negative. But the Y's, you're still going up, so those are still going to be positive. In quadrant 3, you're going left and down from the origin to get to these points. So both the X and the Y are going to be negative for these 3 points, these 3 ordered pairs. In quadrant 4, you're going from the origin, you're going right and down, right and down. So that's positive for the X, it's to the right, but it's negative for the Y because it's going down. So just the Y is going to be negative for these. The X's will stay positive. But other than that, the numbers remain the same. So everything that's highlighted in blue should be the root 3 over 2 for the X and the 1/2 for the Y. But we've already marked if they should be positive or negative. So then I want you to take the time to go ahead and fill those in, and then we will check those tomorrow. Okay? So you should have a little bit of class time left. If you started at the beginning of class, you probably have 10 or 15 minutes left. So you need to go ahead and use that time to try and fill in the rest of these ordered pairs. And then you can take a little break if you have any time left after that. And then we'll pick up there tomorrow. So when we come in tomorrow, your units circle all of the angles in degrees and radians, and all of the ordered pairs should all be filled in. These blanks in each quadrant will be blank, and here where it says tangent outside those ordered pairs will all be blank still, but the rest of those coordinates should be filled in. All right, I will see y'all tomorrow.